Here I have two drawings. There's a before and after. The before is on the left side, and you'll see that in this beautiful drawing of a person, there are all kinds of particles right here on the inside of the person, and those are supposed to show or represent the particles that are in every type of object, whether it's a solid, liquid, or gas, because everything's made up of moving particles. Now you'll see they're farther apart. Then right beside them, there's a line with air that the wind is blowing up against this person, and you'll see that air particles are closer together. So in the person, they're moving faster. That's what the spacing represents. Whereas in the air, they're moving more slowly. That's why they're closer together. So thermal energy always moves from warmer objects, like in the person, to colder objects, like in the air. So we have this movement of thermal energy. Now, just to review again, thermal energy is in everything, and it's just those moving particles. It's the particles that are moving all around, like my hand here. So because the person has more thermal energy, that's what the TE with the up arrow represents, more thermal energy, then the thermal energy in the particles in the person are going to be transferred or moved, at least some of that energy, into the cold air, because the thermal energy of the cold air is less than the thermal energy of the person. So the jiggling of the particles, some of that motion energy and the thermal energy of the person is going to be shared with the cold air, because again, it moves from warmer objects to colder objects. And the result, if you look over here in the after process, you'll see that the person has less energy. The particles are closer together and moving a little more slowly, but the air starts to move faster because it got some thermal energy from the person. And we call that whole process heat. So thermal energy going from warmer to colder objects is called heat. Here's another example over here. You can see there is a pot or a pan on a burner, and you can see the burner has spaced dots, and those dots represent a lot of thermal energy. That's why the thermal energy arrow is up for the burner, because there's lots of energy. Now, when you first put the pan on the burner, before the thermal energy of the pan is going to be low. You can see the dots spaced closer together. They're not moving very fast. The thermal energy isn't moving very fast, or not the thermal energy. The particles in the pan aren't moving very fast because it's a solid and it hasn't been set on anything warm, so they're close together. But we know that thermal energy always moves from warmer objects to colder objects. So the high thermal energy of this burner is going to be transferred via conduction to the pan here, where the dots are closer together. The particles, I should say, I keep saying dots, but the dots represent the particles. The particles are closer together because they're moving more slowly. And the result is that after, you'll see that the particles in the pan are spaced farther apart. Now, it's still a solid, but it is a very hot solid because metal's a conductor, and a lot of that thermal energy from the burner was passed on to the pan. So the particles in the pan are going to be moving much faster. And again, that process of transferring from the burner, a warmer object, to the pan, a colder object, is called heat. And I also want to point out there are three types of heat. There's conduction, like you see here, but there's also convection and radiation. Now, we could have an argument, you and I, talking about the difference between a truck and a vehicle. And I could say, that car outside is a truck. No, it's a vehicle. It's a truck. It's a vehicle. But that would be a waste of time because they're just two different categories. Both are right. So when I talk about heat and conduction, for example, like in this one, they could both be right, but heat is the big umbrella term. And then there are three types of heat, which are conduction, convection, and radiation. But ultimately, all that heat is, or those three specific types of heat are, is the transfer of thermal energy from something that's warmer to colder. So the energy in the moving particles is being shared with something that doesn't have as much energy, like you saw on the burner here, and also like you saw on the person. We had more energy in the particles of the person than the cold air. So the energy, not the particles themselves, we didn't give part of the person's arm away, but just the energy in the particles was shared with the cold air. And as a result, the person's particles moved a little slower because they gave away some of the energy, but the particles in the cold air moved faster. And that sharing of thermal energy is called heat.